So the drug that I will be using for my public service announcement is called Phenazepam, but it also goes by Bonsai or Bonsai Super Sleep. And I believe this is because it is a muscle relaxant and it overall depresses the CNS, and that is just associated with relaxing. And Bonsai is associated with meditation and relaxing. And I chose this drug because I volunteer at an urgent care. And one time somebody came in on Phenazepam and the ER techs didn't know what it was. So everybody was Googling it. And that just made me really excited to search it up, know more about what was happening since it's clearly not taught very mainstream. So the drug history. So this drug was developed in Soviet Russia in the 1970s, and it's used for a wide variety of disorders like schizophrenia, anxiety, alcohol withdrawal, but it's not legal in America or in most of the West. It's legal still in Russia and in China, though. And it is actually a novel benzodiazepine, but even though benzodiazepines are legal in America, it's not considered fit for human consumption in America. So the history of abuse. So it was called Xanny for this specific instance, and it was abused in Louisiana. It was being sold at gas stations as air fresheners, but the air fresheners were tested and they came up as 100% phenazepam. And they tried to get out of the charges by saying that they weren't selling it for human consumption because it said not for human consumption on the label, but that didn't stop the charges. And then another time is that it was sold by a New York nurse as a party drug. It was sold online on eBay, and these teenagers took it at a party. Unfortunately, one of them, who was 17 years old, passed away. He mixed it with alcohol and he injected it. And I'm not sure how the rest of his friends at the party took it, but they all ended up in the hospital as well. So it has a huge potential for abuse, especially being sold as a party drug, not actually what it's being used for. And after the DEA schedule, it is not federally scheduled by the DEA, but in some states where it was a prominent issue, like in Louisiana, it is considered a controlled substance. And since it is not considered federally scheduled, generally when someone is prosecuted being found with phenazepam, it shares the scheduling of a benzodiazepine, which is Schedule 4. Now, for the mechanism of action, its main neurotransmitter is GABA, and GABA is responsible for inhibition, so it blocks the signal between two cells. And this is what phenazepam affects. It amplifies this, and it encourages chloride ions to flood into the cell, which causes a very relaxing effect on the user. And it promotes sleep, relaxation, and it could even control a seizure. But since it discourages GABA inhibition, the chloride ions are able to go into the cell very easily. And the effects can be physical and mental. So it could literally physically relax muscles, but it also emotionally relaxes people since it affects the CNS. And the overall clinical manifestations on the body, like I already said, it depresses the CNS, it decreases GABA inhibition. And since it's an opioid and a novel benzodiazepine, it has the similar effects on the body. So in the event of a phenazepam overdose, what happens very often is that the person's heartbeat gets too slow to function correctly, and the person unfortunately ends up passing away. And then the body system I chose for phenazepam to affect the most is the endocrine system. The endocrine system includes the brain, And the parts specifically are the pineal gland, the hypothalamus, and the pituitary gland. And all of these have to do a lot with hormones. Also, the thyroid glands, which thyroid is a hormone, and the abdomen, it affects the pancreas and the adrenal gland, which are adrenal glands are affected by hormones. Adrenaline is a hormone, I mean. And the reproductive system, it can affect ovaries in females and testes in males. And then the effects on the endocrine system are that phenazepam is the benzodiazepine, so it affects hormones like progesterone and estrogen and estrone. And a study was done on an induced coma. So I thought that was interesting. But people treated with benzodiazepines during the induced coma had reduced effectiveness of their adrenal glands. And then they did a study for phenazepam stress effect on rats that were suffering from alcohol poisoning. And although it did work, it was very heavily dependent on the dose, which is why it's important to not use it without a doctor's supervision, even though it can have some positive effects for alcohol withdrawal. That leads me to my one interesting fact about the drug, which is that it is often used to combat alcohol withdrawal, but when it is combined with alcohol, this can be deadly. And that is because phenazepam has a synergistic effect with alcohol. So basically the effects of that CNS depressing effect can double once you take both. So that is what causes the heart rate to become too low. And another thing I thought was interesting, just thinking about it practically, if someone's going through alcohol withdrawal, there's a huge chance they have alcohol in their system already. So combining that with phenazepam can be very deadly. Or somebody I think could even take the phenazepam and decide it isn't working and try to speed it up with the alcohol, because that's what looked like a lot of the overdoses were when it was mixed with alcohol. So it seems like there's some misinformation in the public about mixing opioids. So even though it sounds like it makes sense to reduce your alcohol withdrawal symptoms, if you really look into the neuroscience behind it, it can cause death. And then the pharmacokinetics, it's usually taken orally. I have these little orange tablets right here. But when it's used as a party drug, it is also often injected, snorted, because they come in pills. So when it's prescribed, I believe that it would be used as a pill. And then since it's a benzodiazepine, it easily crosses the blood-brain barrier and affects the CNS. It's lipid-based, so that makes it cross the blood-brain barrier very easily. And it could also cross the placental barrier because placental barrier also takes in lipids very easily. And then it has an active metabolite. That's this 3-hydroxyphenazepam, and it is mostly metabolized by the liver. The metabolite is active, so that keeps people high for a long time. That's why it has a half-life of up to 60 hours. So that was my presentation on phenazepam. Thank you so much. Hope you learned more about it.